Polar example 10. Polar goes on and on forever. It says find the area inside r equals 3 sine of theta and outside r equals 2 minus sine of theta. We need to graph both of these. 3 sine of theta is a circle oriented on the y-axis because it's sine, and it's going to go up 1, 2, 3, and it's going to look like this. Whoops, it's kind of crappy. Hold on. Well, okay. Kind of like that. It's a little lopsided, but it'll do. And then 2 minus sine of theta is a, let's go back to my little chart, is a limacine, where 2 is less than 1, so that means A is less than B, so A divided by B is less than, it doesn't have an inner loop. 2 minus sine of theta, where A, here, let's just do it, 2 minus sine of theta, so A is 2, B is 1, and 2 over 1 looks like this. Whoops, looks like this. A convex limacine. It's a convex limacine. Do not have my limacines memorized. I need to have them, but I don't. Here they are. So I'm just going to do my quadrantal angle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to fill this in. 2 minus sine of 0 is going to be 2. 2 minus sine of pi over 2 is 1. 2 minus sine of pi is 2. 2 minus sine of 3 pi over 2 is going to be 3, because that's going to be a negative. And then that's going to be back to 2. So let's plot these points. At 0, it's 2. So here, at pi over 2, it's 1. At pi, it's 2. 3 pi over 2, it's 3. And back to 2. So it actually kind of looks like it flattens and then it comes around. And if we're not sure, we can always graph it on our calculator to check ourselves. And to graph in polar, not 100% sure, I've shown you how to graph in polar on a previous video. I'm going to do 3 sine of theta. And then I also want to do 2 minus sine of theta. Whoa, whoops. 2 minus sine of theta. Yeah, it's convex limacine there. Okay, so what I want to do is I want to find the area inside of 3 sine of theta, but outside this one. So I want this area. Okay, so what I have to do is I need to find the area of the circle, and I need to subtract away the area from this point all the way over to this point. So the first thing I need to do is I need to find out where they cross. Okay, to find out where they cross, I set them equal. Get all my signs on one side. So 4 sine of theta equals 2 divided by 4. So sine of theta is 1/2. Where is sine a half? Well, sine is a half at pi over 6. If you look at your picture here, I would imagine that this is pi over 6. And I also need the value in the second quadrant. Sine is also a half at 5 pi over 6. Okay, so let's see if this makes sense. I need essentially the area of the outside minus the area of the inside. Well, the area of the outside from pi over 6 to 5 pi over 6, 1/2 from pi over 6 to 5 pi over 6, pi. It's the area of the outside. Well, the outside is my circle, which is my 3 sine of theta, 3 sine of theta. And then this one is 2 minus sine of theta. So area of the outside, 3 sine of theta squared d theta. And I'm going to subtract away the area of my inside. I can do it as a separate integral, but it's also going from pi over 6 to 5 pi over 6. So we can actually get rid of this d theta and just use it as 1 integral 2 minus sine of theta squared d theta. So it's just outside minus inside. Or you can kind of think of it as, again, your r, your farthest r minus your closest r. I don't know if, and I'm finding the area of the pink. So I know this is hard, I know this is confusing, and we're going to spend a good bit of time on this. So maybe by the end of the 15 examples or whatever I have, you'll start to understand it a little bit.